Okay, this is section 9.4, and we are solving polynomial equations in factored form. The first thing we need for this section is the zero product property. So if a and b are real numbers, and we know that a times b equals 0, then it must be true that a equals 0 or b equals 0. So we can use this fact to help us solve polynomials. The solutions that we get are also called roots of these equations, and we'll see more of that later. But if we want to solve x minus 4 times x plus 2 equals 0, what we're going to have to do is set each part equal to 0, because there's actually two values that would make this equation 0. So we're going to take x minus 4 equal to 0, and x plus 2 equal to 0. Because remember, if 0 times anything is 0, so if x minus 4 equals 0, then that will make the equation 0. Or if x plus 2 equals 0, that will make the whole thing 0. So to solve for x here, we're just going to add 4 to both sides, and then we know that x equals 4. On the other side, we're going to subtract 2 from both sides, and we know x equals negative 2. So in other words, x equals 4 or negative 2. Okay, and think about that. If we plugged it back into that equation, either one of those, we would get 0. If we did 4 minus 4 times 4 plus 2, well, 4 minus 4 is 0, 4 plus 2 is 6, 0 times 6 is 0. Or, for the other one, if we did negative 2 minus 4 times negative 2 plus 2, well, negative 6 times 0 is still 0. So the important thing to realize here is that both of these are solutions or roots for this equation. So here's another example. If we know x minus 5 times x minus 1 equals 0, what are the solutions for this equation? Now keep in mind, in all the sections before this in chapter 9, we were just simplifying. So now that we have an equal sign, we have an equation, and so we're no longer just simplifying, we're actually solving. So again, I'm going to take each side, each part of that product, and set it equal to 0. So if I add 5 to both sides, x equals 5, and if I add 1 to both sides, x equals 1. So in other words, to make this equation 0, x equals 5 or 1. So both examples we've seen so far were both already factored for us. So now that's going to be our next challenge, is trying to factor an equation before we solve it. So we do that sometimes by taking out the greatest common factor. And when we're dealing with polynomials, that could be a number, a variable, or a combination of a number and a variable. So for example, if we want to factor out the greatest common monomial factor, we're going to look at what's the largest number they have in common, or what's their GCF. So 12x plus 42y, they have two different variables, so those are going to stay. But 12 and 42 have a greatest common factor of 6, because 6 times 2 is 12, and 6 times 7 is 42. So if I take out a 6, I'm left with 2x plus 7y. Now, if you're wondering, how did I know that's what I was left with? What I was doing was taking each term in the polynomial and dividing by 6. Well, 12x divided by 6 is just 2x, and 42y divided by 6 is just 7y. Okay, and on the other side we have something very similar, for example b, but this time they do have variables in common. So we have 4x to the fourth plus 24x cubed. Well, 4 goes into 24, so we know they have a 4 in common. But they also have an x cubed in common. So to show you what's happening here, if I divide by 4x cubed, four divided by 4, x to the fourth divided by x cubed, this goes back to chapter 8, is just x. 4 minus 3 is 1. And x cubed divided by x cubed, that cancels. Anything divided by itself is 1. And 24 divided by 4 is 6. So what I'm left with is x plus 6. I factored out a 4x cubed. So one way to think about it is kind of like reverse distribution. So if I were to distribute this 4x cubed inside, I would get what I started with. So it's kind of like going backwards. So going back to our first goal of solving, if we're given an equation where it's not already factored, we need to factor first, again by looking for the GCF, and then setting each of those parts of the product equal to 0. So here I have 2x squared plus 8x equals 0, while 2 will go into 8, so I can take out a 2 definitely. And then I have an x squared and an x. So what they have in common is an x. So again, 2x squared divided by 2x leaves me with an x, and 8x divided by 2x leaves me with 4. So when I kind of undistribute or factor out a 2x, I'm left with x plus 4 equals 0. And again, if I distributed, I would get 2x times x is 2x squared, 2x times 4 is 8x. So you can always multiply it back to make sure that you factored correctly. But if I want to solve, I'm going to set each part of this product equal to 0. So 2x is equal to 0, and x plus 4 is equal to 0. Now, to solve for x, just divide by 2. 0 divided by anything is 0. Subtract 4, and x equals negative 4. So x is equal to 0 and negative 4. And for one more example, this time we have an equation where we have variables on both sides. So before we can solve, we need to get all of the variables on the same side and then do the same thing we did before. So if I have 6n squared equals 15n, I can subtract 15n from both sides. So I get 6n squared minus 15n equal to 0. And now notice that looks just like my last couple problems. So 6n squared and 15n, 6 and 15, their greatest common factor is going to be 3, and n squared and n both share an n. So if I take out a 3n, again, write it out if it helps you, and just to be sure. So I'm left with 2n. N squared minus 2 minus 1 is 1, so I'm left with 2n minus 15n divided by 3n leaves me with 5. So 2n minus 5 equal to 0. And again, I can multiply to make sure. 3n times 2n is 6n squared. 3n times negative 5 is minus 15n. And now I'm just going to set each side equal to 0, or each part of the product. So 3n equals 0, and 2n minus 5 equals 0. Here I just get n equals 0, and here I'm going to add 5 first. I get 2n equals 5, then divide by 2, and n equals 5 over 2, or 5 halves. And that's fine, we can just leave it as a fraction. So in this case, n equals 0, and n equals 5 halves. And that is it for this section.